In this example, we try to find the values of x and y using the fact that other angle measures are provided. So notice this is a somewhat of a complex figure. You might be lost when trying to find x and y because you're thinking, oh, there's so many arrowheads here, so many rays, etc. But don't be thrown off by this. Notice that first of all, there are two parallel lines. And you just have to understand how x and y relate to the fact that there are two parallel lines and a transversal. So you can think of this crossing ray here as a transversal that traverses the parallel two lines, or line segments in this case. Right, so we can indicate this, that this is a transversal line. All right, so if you know that this is a transversal, you can safely say that x and 65 have matching corners, okay? Because they're both to the left of the parallel lines and they're both above the transversal, so they're matching corners, okay? So we know that x and 65 are corresponding angles. And we know corresponding angles when it comes to parallel lines are equal in measure. Right? So we can safely say that x is equal to 65 degrees. So x is 65. Now how do you solve for the y? There are two ways of doing that. You can use vertical angles. For example, this angle here is the same as the y because this angle and the y are vertical angles. So you can safely say that this is y as well. So now that you found the x, you know that the sum of x, y, and 55 is equal to 180 degrees, right? Because this is a straight line segment. So this is a straight angle that is made up of three angles, x, y, and 55. That's one way of doing it. The second way is to write the 55 here, because this is a second pair of vertical angles, right? So you can write 55 degrees here because you know that this angle and this angle are vertical angles. And vertical angles are equal in measure because they are formed by two intersecting lines. So two ways, either you make this sum of x, 55, and y equal to 180, or you make x, y, and 55 equal to 180. But notice we're dealing with the same exact angles, right, when it comes to the measures. We know the x that is shared in these two methods. We know the y that's shared. And we know the 55 that's shared, right? So either way it's going to work. So let's just write the equation. X plus y plus 55 is equal to 180. We know that the x value is 65, right? We know that. We just found that. So we can substitute this in and write 65 plus y plus 55, and I'm just writing degrees, it's the same thing, is equal to 180 degrees. All right, so we know essentially that we can now add these two guys together. So as a result of which y, let me put degrees here, plus 65 plus 55 is going to be what? It's going to be 110 plus 10, which is 120. Okay, is equal to 180 degrees. So if you subtract 120, you should get the correct answer, right? So the result of which is going to be the y, which is equal to 60 degrees. So y is equal to 60 degrees. And if you want to check that, you can go ahead and do that. One way to check the y is to check with the 55 and x, or using this one, this straight angle or this straight angle, or you can check the y with this angle here, because this angle, believe it or not, will be the corresponding angle with the 55, right? Because 55 and this angle are matching corners. Notice that. Right? This is also 55 because both of these angles are to the left of the parallel lines and also they're below the transversal. You can think of this as another transversal. So 55 and that 55 are the same. So you can check the y value using the fact that the sum of these three is equal to 180 degrees. Right? So 55 plus 65 plus 60 should give you 180. And precisely that will be true. So y of 60 degrees is absolutely correct and makes sense. Thank you so much for watching. Hope this was helpful. See you in the next video.